One of the questions we're faced as an IT professional is whether we should acquire skills to program. Now, programming is a powerful skill. It's a skill that significantly enhances capabilities. It enables tasks that would otherwise be impractical to accomplish. However, this programming skill doesn't have to be at the expense of your current skill set. Rather, it can augment your current abilities by addressing the repetitive and mundane tasks, while you can apply your current expertise for more essential tasks that require your functional skills. As with every discipline, there is a significant trend toward automation. Task automation has been trending for several years, so it shouldn't be a surprise that it finally appears in the area of networking and security. It's no secret that we should be automating a lot of things that we have previously been doing manually. Automation is where Python can help. No introduction to Python would be complete without sharing Python's history and origins. In December 1989, during the Christmas break in the Netherlands, Guido van Rossum, an employee of the Centrum Wiskunde and Informatica, searched for a hobby programming project to keep him occupied during the break. As a master's degree graduate in mathematics and computer science, this was not an activity that was out of the ordinary. In fact, he'd been thinking about this endeavor for quite a while. That is, a programming language that would be a direct descendant of the ABC programming language that he co-authored with Lambert Mertens, a co-worker at CWI. So he decided to write an interpreter for the new language. He attributes the name Python due to the fact that he was a big fan of Monty Python's Flying Circus. This new scripting language prioritized readability and writability, as well as adhered to object-oriented tenants, which combined would assist expert and beginner programmers alike to write exact, logical code for small and large projects. The language was so popular, he ended up formalizing its release in 1991. In 1999, Guido approached DARPA, D-A-R-P-A, for their further funding, coining the Python language project the Computer Programming for Everybody proposal. In this proposal, he further defined his goals for his Python language. 1. An easy and intuitive language just as powerful as its major competitors. 2. Open source, so anyone can contribute to its development. 3. Code that is understandable as plain English. And 4. Suitability for everyday tasks, allowing for short development times. In 2018, Python was the third most popular language on GitHub, a social coding website, behind that of JavaScript and Java. According to the Programming Language Popularity Survey, Python is consistently among the top 10 mentioned languages in job postings. Furthermore, Python has been among the 10 most popular programming languages every year since 2004, according to the Programming Community Index maintained by the TIOBE company in Eindhoven, Netherlands. As we push forward, let's take a moment to fully understand, with all the available languages out there, why Python seemed to rapidly captivate the programming community. Well, at this juncture, all we can really do is recite facts. Python is exceptionally readable. Readability means the syntax is relatively straightforward and intuitive. This readability places it first among beginning programming languages. Now, however, when we say first among beginning programming languages, we by all means do not mean that it's less than any other languages that are available. Python is immensely powerful and can do anything one could ask a computer to do. What we mean when we say a preferred beginner language is that Python is written in a common language that is both familiar to expert coders and understandable to beginners. Code is essential for both security and network engineers alike, but coding is not necessarily going to be the focus of their job. Conversely, a software developer can afford to learn complex languages such as Java, C++, C#, where a network and security engineer may not have time for such long-term investment. This is why, for security and network engineers, a language like Python is a great choice, for it's powerful but simple to learn. Specifically, Python is a very high-level language. It doesn't need a lot of glue code to get things done. There's no need for a manual cleanup. For example, there's no garbage collection function in Python. In addition, there's no memory allocation or deallocation required either. And to formally declare variable types before they can be used in a program, that has gone the wayside with Python's dynamically variable typing capability. It's principles like these that make Python an easy adoption choice. Now that we have some idea of the characteristics of Python, perhaps it'd be prudent to go through some of the syntactical elements of the language. For starters, one of the essential aspects of Python as a programming language is that blocks of code are indicated by indentation. Usually 4 spaces, but indented nonetheless. Now, let's look at this example specifics here. Trying to ignore the complexity presented, let's see if we can give you at least some basic takeaways. First of all, you'll see that lines that say if, elif, and else. Well, this is a function that has 3 control statements that govern over indented executable lines. Now, we know they are control statements for the end with a colon. Now, for the if and elif control statements, they present a criteria to be evaluated. Now, if this criteria evaluates true, then their indented lines immediately below them will be executed. And then they proceed out of the function entirely, go to the next statement. However, if they evaluate false, they move to the next internal control statement. Like, for example, if would go to elif, elif would go to else if they evaluate false. For example, the if statement presents a condition to evaluate before proceeding or moving to the elif. So in this case, the contents of this variable called my variable, which we randomly named, to be evaluated against the integer 2. So if the contents of my variable equals 2, then the statement evaluates as true, and then you can proceed to executing the 4 statements indented immediately below the if control statement. Now, if they evaluate as false, they shoot out of it and go to the elif statement, which has its own criteria to be evaluated to see if its own indented code to be executed. Now, if these 2 conditionals fail, we proceed to the final alternative else, which has a single line to be executed without the need to evaluate anything. And once complete, we go back to the previously indentation level and continue, which in this case happens to be the for loop statement. Note that isn't part of the else statement because it's not indented. So the takeaway is blocks of code are indented and are subject to the control statement that has ended with a colon. Simple enough. Finally, before we complete this introduction, we'll walk through the most rudimentary form of information that Python uses to communicate between processes, the data structure. Data structures are a way of organizing and storing data so they can be accessed and worked with efficiently. They define the relationship between data and the operations that can be performed on the data. There are various kinds of data structures defined that make it easier for data scientists and computer engineers alike to concentrate on the main picture of solving larger problems rather than getting lost in the details of data description and access. Let's dig in a little deeper with Python's data types and data structures. As stated in the introduction, data structures help you focus on the bigger picture rather than getting lost in the details. This is known as data abstraction. Data abstraction comes from the object-oriented world. If you remember, Guido included object-oriented programming tenants in his interpreter. So naturally, data abstraction is part of Python. To understand data abstraction further, let's say you have a mechanism called coffee maker. Now, you know how to put the coffee caplet in its holder, pour the water in the back of the reservoir, and select the buttons for latte or Americano. But what you're not familiar with in the coffee maker is the temperature of the heating coil, the amount of water in the reservoir, the temperature of the water, the amount of water dispatched through the caplet, the duration of the steam water jet, the amount of steamed water dispatched to make a latte versus an Americano. Subsequently, the data abstraction name of coffee maker is the only thing you really care about. It's these data structures that hold the detailed information so you don't have to care about them. Just calling out coffee maker does the trick. Generally, data structures can be divided into 2 categories in computer science: primitive and non-primitive data structures. Primitive data structures are the simplest form of representing data, whereas non-primitive data structures are more advanced. Non-primitive data structures contain primitive data structures and have more complex data structures for special purposes. So that'll be outside the scope of this introduction. We'll focus on primitive data structures. As far as primitive data structures go, they are the building blocks for data manipulation and contain pure, simple values of data. Python has 4 primitive variable types: integers, floats, Boolean, and strings. The first category of primitive data structures is integers. You can use an integer to represent numeric data, and more specifically, whole numbers from negative infinity to infinity. This includes all negative whole numbers, 0, and all positive whole numbers. The next category of primitive data structures is floats. Float stands for floating point number. You can use it for rational numbers, usually ending with a decimal figure, such as 1.11 or 3.14. This is when you divide a whole number by another whole number, like 5 divided by 2, and ends up with a number like 2.5. Without the float type, you would end up with a 2 as the answer, and this is grossly in error. Floats ensure a tighter accuracy for mathematical calculations. This brings us to the primitive data structure of Boolean. This built-in data structure type can take up a value of true or false, which makes them interchangeable with the integers 1 and 0, 1 representing true and 0 representing false. Booleans are useful in conditional and comparison expressions, such as when you say x equals 4 and y equals 2, then if you write x equals equals, which is a Boolean expression of comparing the two, equals equals y, then that would be false because x equals 4 and y equals 2, and they don't evaluate to be the same thing. So the Boolean data structure of false is returned. And in the same vernacular, is x greater than y? Well, using the criteria we mentioned earlier, x being 4 and y equal 2, well, yes, that's true. So then the Boolean expression of true is returned. Finally, this brings us to the most common primitive data structure, the string. Strings are a collection of alphabets, words, or other characters. In Python, you can create strings by enclosing a sequence of characters within a pair of single or double quotes. For example, x equals cake in single quotes, or y equals cookie in double quotes. It won't matter because when you put them together in the expression x plus single quote and ampersand single quote plus y, this expression just simply states concatenate the contents of x with the string value of ampersand and concatenate that with the contents of y, leaving you with the result of cake and cookie. We hope you enjoyed this introduction to programming and the features and benefits of Python. Hopefully this narrative has given you a nice introduction of who, what, where, and why Python is the chosen language for the future. We believe that features like ease of readability, portability, natural language approach, and the ability to use other languages to enhance your performance are argument enough to investigate Python as a viable choice for your programming language in your tool belt. With that, we wish you the very best and happy coding.